Hi there. Welcome to the 345 Tech Talks podcast. I'm Andrew. I'm with Danny, and we are both in the solutions team at 345. And today we are going to talk about what is a model, demystifying AI, demystifying machine learning. So that is today's topic. Let's go, Danny.
Yeah, so last week we spoke about how we start with AI and just those couple of questions around how people get started and the fact that some people are quite worried or maybe scared and not too sure as to where to start. So we had a really good chat about how to call an API and the fact that there's lots of models out there that people can already integrate into their own business. That today I'm looking forward to us talking around what is a model and how it would look to a prospective user in various different businesses. So really looking forward to having that. And I know you've got some really cool slides that you're going to put into this video, which
don't big them up too much.
But this is the perfect way to explain how AI can really benefit a lot of different business out there. So in various different industries. So yeah, looking forward to this.
Great. Okay. So where do we start then? Shall we start by let me get the presentation up. That would be a great place to start. So one of the things that usually happens when people start to talk about models is that they get presented with a picture like this. And the letters W, T, and F usually then follow soon after. People say, okay, what's that? Let's do AI. And then you see a picture like this. So that's a model. And I mean, so one of the things I'll first do is just sort of explain why it is that people use a diagram like this. And the reason is because, well, I suppose the important thing about an AI model to understand, when you say what is a model is a mathematical calculation. And that's it. That is purely what a model is. So when you see something written like this, what effectively it means is that each of the blobs in a model like this represents a number, and each of the lines represents a calculation on those numbers. So it's not, so if you're a mathematician or you're a data scientist, you can kind of get that because okay, there's numbers and there's calculations on those numbers. But that's what a model, when you see a drawing like this representing AI, it means this is, this is numbers and relationships between numbers. So if I actually just go forwards a little bit, what that would mean in terms of, if you're looking at programming, you'd say, okay, when we looked at that model, you've got the blobs on the left usually represent inputs, and the blobs on the right represent outputs. But that is all, and stuff happens in the middle. So when you run an AI model, whether it's an image recognition or whether it's a fraud detection or whether it's speech recognition, effectively all you're doing is you're saying, here's a bunch of numbers, do a calculation on them, and then a bunch of numbers come out the other end. Sometimes it's a small number, like in this case, you've got two numbers come out, and sometimes it's a big, sometimes there's a whole ton of numbers come out. But ultimately, that's all it is. An AI model is just a mathematical calculation that takes a bunch of numbers in at one end and gives you some numbers at the other end. So that's both very, that kind of has its own, there's a lot of implications of that. So, for example, you say, well, how do you do image recognition? Well, each pixel in an image is a number. So all you do is you literally pass in, so for example, 100 pixel by 100 pixel image is actually 10,000 numbers. You can pass that in, and that's how you do image recognition. It's literally your input in that case would be 10,000 different numbers. Or if you had, a really high resolution image, it might be tens of millions of numbers. But that's what but that's what a model looks like. And again, depending on what, and the output just depends on what the question you're asking is. So, and this is why things like, categorization is a really, really good application for machine learning. Is this apple a good apple or a bad apple? Well, what you do is those two numbers on the output, one would represent good and one would represent bad. So you'd put a photo in of your apple and say, is this a good apple or a bad apple? And either one or other of those numbers on the right would have a value in it. And that's how it works. So I suppose the difficulty there isn't in what a model is. It's the fact that it's how that calculation is set up. So because how all the different numbers in that model interrelate is where all the hard bit is. So I was just going to talk briefly about the difference between programming and machine learning, because we can start to get our head around it with that. So when you're programming, you're generally speaking, let's say you were going to program a calculation, you'd be given, you give a program a specification and say, so let's say it was for calculating the APR on a bank loan. You give them a specification, a document that says, okay, here's the equation for this. You've got these inputs, and you write the calculation like this, and that goes into the process. The programmer does programming, so he turns that into computer code, and out of that comes a function. And then, okay, you've got some test cases for that, so you do some testing, and then at the end of it, you've got a tested function. So that's how in traditional programming, that's how you'd create a calculation that took in a bunch of numbers and put some numbers out the other side. Machine learning, what you do in machine learning though is you take a very different approach. Is that you basically take the data you want to put in and the answer that you want to get, and that's called training data. And you go through a process of training, which is so because all those little lines in that model that we saw, they are all effectively they are all a little dial that you can tweak. And what the training process is you put data in, and it tweak, and the training process tweaks all the little dials in that model to say for how those numbers multiply together to give you the output. So instead of actually knowing how they all interrelate and knowing how they multiply at the start, you actually do that by passing data to it. And so you start off with a model that is, a bare model where all those little knobs and dials are set to their default position, and you have an algorithm that is the one that tweaks those knobs and dials, and then you have something called a loss function, which actually tells you how wrong you are and how much you need to tweak those dials, and you just go over that again and again and again and again until the model gives you the best answer you can. And so, and that's how you arrive at this mathematical calculation. And then you have, another set of data, which is test data, which should be different from your training data. And you run that through tests, and then you have a tested function. But really, back to what we had before, a machine learning model is just a mathematical calculation. The hard part is in the training of it, because that is the bit where you're running thousands and thousands and thousands of calculations to just tweak all those little knobs and dials to say that's what the calculation does. But it's inferred from data rather than it being known beforehand as an equation. So that really, in a nutshell, that is what a model is. So what do you make of that, Danny?
It's I mean, this is one of the fascinating things around machine learning and AI, and we've spoke about it many times before, probably for too long, and our imagination runs wild, because you can have a start position and a target or a goal or an end position, and what machine learning will do is ultimately get you there. And the nice thing about it is, if you're creating it yourself, that makes it even more enjoyable. But also at the same time, if you're calling an API that's already there, ready for you to use, again, you are finding a start point and ultimately looking at a goal, whether that's a growth within business or data that you really want to analyze a little bit more, to create potentially a saving model within business itself commercially. That's the fascinating part of it, is being able to help ultimately. So yeah, we certainly talk a lot internally about all the types of machine learning and AI possibilities that there are out there. And I think actually you mentioned things like face recognition right at the very top. And I think in the current climate where we are now, I think AI is going to become a little bit more prominent, and maybe a little bit quicker than maybe it would have done before the current situation that we're in. So yeah, fascinating and exciting to see how that develops.
Yeah, and just just adding on to that, I mean, over the next episodes, we're going to start looking at some of the scenarios where we can use that and how those models fit together. But really, what we're trying to do is just take everyone step by step through that journey, because if people are on the outside and they're just looking in, this just looks like mind-bending stuff.
Yeah.
And okay, it's the principle. It is really clever stuff. It's really clever stuff. And the principles of it are well established. But what I think what we want to show people is that that it's become a usable toolkit now. And so and we talk to people week in, week out on how you use that toolkit to solve problems for your individual business. So hang in there. It's not all going to blow your mind. It's more about how you can actually use this toolkit and then do amazing things.
Absolutely.
So on that note, I think next week, so we've been demystifying what a model is. I think next week we will talk a little bit about what deep learning is, which is sort of the next leap on AI, and then after that we'll start talking about applying this stuff. So thanks a lot for listening.
Brilliant.
And we will catch you next time. All right, bye now.
Take care.